So I'm on my last video that's going to be required. I don't even remember which one this one is, 6, 7, 8, something like that. I know this has been a lot of videos to watch, but I think if you will refer back to them and get factoring down right now, it'll make your life a lot easier in lessons to come, because we're going to factor for the rest of the school year, and you will factor all the way up through calculus. I mean, factoring is a big deal. Okay, I'm going to quit preaching. I want to show you that another page that I'm going to provide you is this page. Every single one of these methods, guess and check, grouping, this is going to be the one that I'm going to model because it's the one that Miss Trevino and I think it's our favorite. The box method, the diamond method, slide and divide. I actually call this divide and slide. These are all methods that will do the exact same thing. I don't care which one you use. I don't care if you use a different one every time. I just want you to be able to do it. And when I say do it, what I mean is I want you to be able to factor a trinomial whose A is not 1. Right here. This is a trinomial. So let me take you through the factoring flowchart. Does this problem have a GCF? Is there a GCF? And the answer is no. 3 is a prime number, 11 is a prime number. You can't have a GCF if you've got prime numbers in your problem. So the answer is there a greatest common factor? No. How many terms? 3. Is this a perfect square trinomial? No. 3 is not a perfect square, neither is 10. Is the leading coefficient, or is the coefficient of the squared term 1? The answer, does A equal 1? That's really the way I would rather have that read, either the leading coefficient or A. Is it 1? The answer is no. Then it says factor the long way using the AC method. Okay, so the AC method, all of these methods that were on this other page, they all, except for this one right here, they all involve the AC method in some form or fashion, okay? And because the AC method just simply means, see right here, by grouping, multiply AC. So really and truly, with the exception of this guess and check, all of these could be called the AC method, because they're going to require you to multiply A times C. Right there, multiply A times C. This one, oh, there it is. Find the factor, multiply A times C. Multiply A times C. So on all of these, when they tell you to multiply A times C, multiply A times C. Every single one of those. That's why we call it the AC method. So the AC method by itself means that we're going to take this problem and we're going to alter it in just a simple way to kind of get ourselves moving in a direction that will help us factor the problem. Okay, so notice that we haven't done anything with this 4 plus, and we will. That comes later on in the semester. This happens right here. We'll do this after Christmas, or we'll do this. We'll do this second semester. Okay, just like we're doing this second semester, we do this right here, second semester. So this flowchart is not going to go away. We're going to do this second semester. We're going to do this second semester, but you're going to get a taste of it right here, because what we're going to do here in just a second is we are going to change this out of a problem that has 3 terms into a problem that has 4 terms. And then we are going to solve it by factoring. But that's what they mean by doing it the long way. And the long way is just any one of those methods that I have listed on the other page. I'm going to do a separate video, and they're all going to be optional for each one of these things right here. So the first thing I want to do is I'm going to copy and paste these notes over here so that as I work them out through this problem, you'll be able to see what they are. So we'll be following these notes as I work this problem, okay? But again, I will go back and do separate optional videos for the guess and check, for the box method, for the diamond method, and for the divide and slide. Okay, so those will be optional videos. You do not have to watch them. Everybody's going to be required to watch factor by grouping, but then the rest of them will be optional. Okay, so enough talk. We're down here. We said, does A equal 1? No, so we've got to factor the long way using the AC method. And first of all, notice that the very first step it says factor out a GCF. Well, we've already tested it to see that the GCF doesn't come out, okay? So the next thing it says multiply, remember, A right here is 10, B is 11, and C equals 3. So when they ask us to find AC, that means they're asking us to multiply 10 times 3 and get 30. So multiply A times C. Now it's asking us, I'm going to slide this over just a smidge so I can slide this over. Now it's saying, okay, so they still want us to do that same factor sum table that we did a while ago, but this time we're doing it a little bit different. Okay, and the thing that's different is we're still using the sum right here of 11, but we're finding factors of 30. We're finding factors of that AC. Okay, so that's where it's normally we just find factors of 3, but because we have this 10 up here, we have to do the AC method, and the AC method says multiply A times C, and those we're going to find factors of 30. Numbers that multiply together give me 30. Let's say 15 times 2, and it is a positive 30 because a positive 10 times a positive 3 is a positive 30. So those multiply together to give me 30, and they're going to add 15 plus 2, they're going to give me 17. So that's not what I need. I want factors of, I want them to add together to be 11. So let's see what else. 10 times 3. 10 times 3 will give me 30, but 10 plus 3 gives me 13, so I'm a little bit closer. What about 5 times 6? 5 times 6 multiplies together to give me 30, and 5 plus 6 adds together to give me 11. So 5 and 6 are the pair of factors that I want. So here's the other thing that it says, okay? It says multiply A times C, we did that. Find 2 factors of AC that add or subtract to give me B. Remember, here's B. So I did that part. So this is step number 2. This is step number 2 right here. This is step number 3. Now here comes step number 4. Split the B term into into sum of those 2 numbers. So we're going to take these 2 numbers, and last time they were factors. This time we're going to split that 11 right there into a 5x plus a 6x. Okay, we took this 11 right here and we split it into these 2 things right here. So this is what comes over here this time. That's where we got the 5x and the 6x. So those 2 right there add together to give me 11. Now do you see that we have a problem that has 4 terms? And so it has 4 terms. Now, yes, 2 of them are like, but we've split it up and made it 4 terms because I want to be able to factor by grouping. And when I factor by grouping, I'm going to do exactly what it says. I'm going to take these 2 terms and consider them a problem, and I'm going to take these two terms and pretend like they are their own problem. Okay, so these two terms right here, I'm going to factor out a GCF from these two. It looks like they both have a 5x. Remember, factoring out a GCF means undistribute. So 10x, if you pull out a 5x, that's going to leave you a 2x. Now, if you're not understanding what I'm doing, I'm saying 10 right here is 2 times 5 times x times x. That's what 10x squared is. And then this right here is going to be 5 times x. And what do these two have in common? The 5x. The 5x right there and the 5x right there. That's what I factored out. What was left up here, the 2x was left. And then if I factored everything out right there, don't forget there's always a times 1. Because if you factor everything else, you have to leave that ninja 1 to be the placeholder. Okay, so I undistributed the 5x. I pulled out the GCF. Now I'm going to do the same thing for this one. So this 6x right here can be factored into 2 times 3 times x, and this right here is 3 times 1. Okay, what's a factor that they both have? They both have that 3. So I'm going to factor out the 3, undistribute the 3. If I take the 3 out, that's going to leave me a 2x plus 1. Okay, so now that I've taken this problem and grouped these two together, factored out a GCF, did these two together, factored out a 3. Notice that the part that's left right here with each one of them, that's now a common factor. This term is being multiplied by 2x plus 1, and this term right here is being multiplied by 2x plus 1. So 2x plus 1 gets to be the GCF that gets factored out. And so if I undistribute this 2x plus 1, I have 5x plus 3 that's left. Okay, so what that means is that I have completely factored this problem by following this process right here. I factored out a GCF, it didn't have one. I multiplied A times C. I built my factor sum table. After I found the proper terms, I took the sum right here and split this into the 11 into 2 parts. And I put the 5 with the 10 because I knew they were common factors. I put the 6 with the 3 because I knew they had a common factor. And then I factored out a GCF here, factored out a GCF here, and then lastly, factored out this last GCF. And this is the final factorization. I know that that one example is not enough. So I am out of time for this video. But I will do some additional videos that are not mandatory, they're optional, where I will do this problem or another problem like this one following these rules, and I will also do all of the other ones. But for right now, I'm finished with this video.